So yeah, I want to talk today about Kubernetes was come and born in the cloud. The whole cloud native was started there. And of course, it's growing there as well. But are there other areas where it is growing or it will grow in the future? Let's look into the reality. So in most things, when we are doing day by day our stuff, it's not only running in the cloud. We are connecting processes together. And not only the processes can run in the cloud. So we have some stuff on-site running. So everyone from us is using edge devices like small smartphones or have IoT devices in her home, routers, things like that. And all of this gets connected more and more together. But the challenge is now, how do we provision and how do we leveraging the same software development skills, the same infrastructure, and the same way how we do it in the cloud, also in these areas. But before we look into this, let's first potentially look into what it is. What is edge? So there are a lot of different definitions of edge. I think everyone from us is familiar with the cloud or bigger data centers, but then it already starts diverging. So we have then some regional edge, which could be like smaller data centers somewhere in the region. And then we have access edge, which is typically at telco sites or close to the end where your network is ending. And then it comes to the user edge, especially in an B2B case, on-premise data centers, your home equipment, and then it comes to smart device edge, like iPhones, IoT devices, and then the latest thing is like really constrained device edge, like microcontroller-based stuff, where we have really only a limited amount of CPU and RAM capacity. And all of this is defined as edge. And every time when we're talking about edge, I think we really need to think about what type of edge we are talking, because everything of this has different requirements, different capabilities. And today, most of the stuff we are developing, and we are talking here about containers, most of the containers still are running in the centralized data centers. But now, more and more stuff is also moving to the other areas as well. And what is the challenge with this? So I want to focus today in like the industrial and edge challenges. I mean, there are a lot of more cases as well. Like, as I said, everyone using smartphones and things like this. It's also edge, but there potentially you have different challenges as well. So let's look into a use case with like Industrial 4.0. I mean, if we think about, for example, an automotive company, and you are producing the cars. So on the one side, you're generating more and more data in real time. You have your robotics, you have intelligent systems to build up these cars, and you get more and more dependent on your also IT infrastructure there. And if you look into the news, I think last week or the week before, one of the big automotive producer needed to stop multiple fabrics because they had problems with their systems. And at the end, it turned out some of their servers went down because they haven't planned enough capacity for their backups. So in this case, the edge is even mission-critical applications. So on the one side, they need to be partly disconnected. If you're losing connection, sometimes you have the requirement to really restart the connections in milliseconds. Similar as we want to have it with Kubernetes, your application, in best case, are starting and restarting in seconds. And when you're losing a node, In best case, you get it up in minutes again, so that you can ensure your production is every time capable, and you don't need to stop your production, because in an industrial case, that's really expensive and really problematic. And I mean, we all heard about ChatGPT and OpenAI. So now, with AI, a lot of new things are coming up. There is already a lot of use cases at the edge where AI is used. Like, for example, when you're producing stuff and you do image recognition to analyze if the good, what you are producing, it's in a good shape or it's waste, you need to sort it out. It's already done. But now with generative AI and other movements in the AI world, even more capabilities are coming up. But this means also you can potentially train your models at the cloud. But executing your models, you need to do it in the shop floor or in the fabric. And if you look into what requirements and how much capacity also AI workloads to execute these models are nowadays having, you also need more and more capabilities in your shop floor to manage this. And of course, in best case, you really want to leveraging similar infrastructure in similar ways how you do it in the cloud. Because the last thing what you want to do is like building complete different ways how you do it in the cloud versus how you do it at the edge or at the shop floor. Because this then, on the one side, requires additional effort, build it twice the same ways. It's more error prone because with one way, you can even better test it, you know it's working. And with have multiple ways, you need more stuff potentially to analyze this, to build this, or the risk is high that you potentially implement some mistakes, which again stops your production. So reliability in this case and efficiency is really, really important. So I think what we really needing and what we currently, or a lot of companies are working on is really cloud native for the edge in different use cases. On the one side, what we need is like existing applications, or what we understand is existing applications are not fully cloud native yet. So when you look into, there are already a lot of use cases at the edge, but a lot of vendors are now putting them into container and say, oh, that's cloud native. In a lot of cases, it's not. It's like a VM packed in a container, and a lot of capabilities is missing. But we also need to understand, like, cloud native and non-cloud native workloads needs to operate side by side, because you cannot change everything at the same time. So you need to have some kind of transition there. And how you operate your existing stuff and how you can implement new modern stuff. But on the other side, the vendors who are producing the software also need to understand that they potentially need to move faster. So giving you a concrete example, we work with a company who built 5G networks. And they packaged this and said, hey, everything is cloud native. But then they said, the requirement for this is to run this. And it was like 2-3 months ago. Max Kubernetes version we are supporting is Kubernetes 1.19, which is already quite old and not supported even anymore. So they also need to understand, if they go the cloud native way, they need to adapt to these new principles, which means they need to leveraging newer version of cloud native, newer version of Kubernetes, and all the tools what they're using in their whole system, and cannot like say, oh, I'm producing a release every 2-3 years and then ship it to the customer. I really need to then following the whole cloud native release journey, so that I have every time updates, every time are on the newest versions. So on the one side, what we need to do with the application is transforming the application from a monolith application into a in best case, microservice application, and also optimizing this. But also, we also need to understand apps are not just apps, they are services. So mostly multiple systems are now talking together, and only if all of this works together and we can all orchestrate them and all manage them in a similar way, then we can ensure that we have a system where we can operate it in a high efficient, but also in a mission critical way. So let's do some reality check. A lot of people are saying Edge competes with the cloud. No, it's not. I think only if the workload is really distributed, we really can leveraging all the benefits what cloud and Edge is giving us. If you're looking into companies, like companies will not buy Edge because of Edge. We really need to understand there need to be a value and an end-to-end integration for the customer so that they really adapt this, moving to this new world and can build up new ways how to operate. Now, with like a lot of new terms are coming out, like AI, 5G, at the edge, cloud native. Cloud native can really help to rethink the use cases. I mean, in a lot of cases, some of the stuff is already existing there, like smartphones are also out there since years. IT is already in the production already like years. But in the past, you needed a long release cycle. You had really static systems. And nowadays, as all the things are changing much quicker, you need to rethink stuff, how you do this, how you operate this. But if you're moving to this new world, it brings you also new opportunities, which potentially before that were not possible. And then the last thing is really, as the system gets more and more complex with a lot of vendors, there is no single vendor solution out there. To implement this, you really need to focus on real-world problems with clean integrations, because all of your vendors need to align on cloud native, but you need to work with a lot of vendors there. And cloud native can really help to streamline this understanding how stuff are operated in the future and how things are integrated. So it makes it easier to integrate and work together and have also like clear boundaries how we operate. And with this, I want to thank you and hand over to the next speaker.